Hi, I am Varun Joshi and I welcome you to Cloud with Varjosh, where we discuss cloud, DevOps, and everything in between. In this lecture, we are going to look at DevSecOps from a DevOps engineer's lens and understand how security actually fits inside a real CI pipeline. We will start with why and what of DevSecOps, then break down key terms you hear everywhere: SAST, DAST, code quality, SCA, and SBOM. From there, we will jump into what SonarQube really is, its role in modern pipelines, and walk through an end to end production grade DevSecOps flow. Then we will get hands on. We will install SonarQube on an EC2 instance, walk through the SonarQube console and architecture, then provision a separate EC2 for Jenkins and install Maven and Docker. Finally, we will put everything together and run a full DevSecOps demo with SonarQube, Maven, and Jenkins. So you see exactly how code quality, code security checks, and CI triggers in real life. The GitHub repo linked in the description has detailed explanations and step by step demos for everything we cover. Replay the labs on your own setup, and if it helped, please do star the repository. With that being said, let's get started. Now, before I start this lecture, I first want to visit the GitHub repository for this lecture so that I can tell you what are the prerequisites for this lecture. So I will go here, I will zoom in a little, YouTube standalone lectures, and from here I'll click on lectures, and then I will go to SonarQube, that is lecture for today. Now, if I scroll down, I'll use the clickable table of contents to go to the prerequisites. And here you see there are three prerequisites. The first one is modern SDLC. Now, we have discussed this deeply in a different series, a series where I am covering Jenkins and CI/CD in greater depth. So we covered modern SDLC and also CI/CD. I would request you to watch both of these lectures because this will give you the foundations. And once your foundations are clear, whatever we are discussing in this lecture, and understand that DevSecOps, SonarQube, all of these are extensions of DevOps. And until and unless you understand the life cycle of DevOps, you will not be able to make sense of this lecture. So in this lecture, we cover modern SDLC, and if I give you a glimpse of it, this is it. And here you see we have covered SDLC, then we have covered different programming languages, and then we have also covered how are these different when deployed onto different environments. So how they behave when you deploy them onto containerized versus non-containerized environments. So this lecture is of utmost importance. And then the next lecture is again the CI/CD lecture. Here I explained different terms. We started from the very basics, that how Git works, a very high level view of that. And then we moved on to different continuous practices that you would see, branching strategies. Then we looked at different production workflows, which you will see. This is Git flow based. Then we discussed what's the promotion strategy. Then we moved on to trunk based CI/CD pipelines. So watch these two lectures. And then the third prerequisite for this lecture is you must understand Maven. Now, I have a detailed tutorial on Maven in this channel itself. The links for that is here. Why this lecture is needed. In the demo section of today's lecture, what we will do is we will be running a full-fledged production grade pipeline demo, wherein we will be integrating Maven with our pipeline, and Maven has plugins that we will be using, and those plugins are the ones that help us integrate Maven with SonarQube. Hence, if you do not understand Maven, which is a popular build tool used for Java language, then this lecture will not make sense. So watch all these 3 lectures, and if you have already done so, then let's get started with this lecture. So the first thing that I want to discuss is why DevSecOps. Late checks cause release failures and rework. Now let's say you have normal CI/CD pipelines, you do not have security integrated with your pipelines yet. Late checks cause release failures and rework. Now imagine if you are using a security tool and that security tool is running when you are deploying the application or right before when the application is deployed, and it finds certain vulnerabilities. Will it make sense to again start from the very scratch and remove those vulnerabilities? It does not make sense. That is why whenever we are discussing about CI/CD pipelines and especially security in CI/CD pipelines, we always say shift left. And what does shift left imply? If this is the flow and we are saying shift left, what that means is if you are performing security analysis in deployment stage, then move it to testing. If you are performing in testing, then you should be performing them in build too. If the security is part of build, then it should be part of development too, and so on. Hence, what we are saying is whenever we talk about security, we should be taking care of security in all the phases of SDLC, of the DevOps life cycle. Varun, but how do I take care of security in the requirement gathering phase? There is no tool that you would use in the requirement gathering phase, but what my intent is, whenever I'm gathering requirements for my application, I should be always thinking about security. If my application teams come to me and tell me that Varun, we would like to have our application deployed onto containers, then my mind should automatically start working that how do I perform security testing, not just for my container images, but also for my running containers. So my mind should be working in that direction from the phase of requirement gathering itself. And then in each phase, security should be given utmost importance. Previously, it was not done like that. Security was part of late checks, but for the past 5-10 years, industry has come to realize that without security, their pipelines or their workloads are futile. Hence, now everyone is taking care of security. They are adhering to shift left approach. Next is manual reviews are slow, inconsistent, and unauditable. And that is obvious. If you are not performing your security scans as part of your CI/CD pipelines, then you are essentially doing that manually. And when you do something manually, what happens is the integration doesn't work as smoothly. Let's say you are performing static scans of your container images, but what I want is my pipeline should not move to the next step until and unless that scan is successful. But how do my pipeline know about that? My pipeline will know only about that when I have integrated that security tooling with my pipelines, or I have an automated way via which I can tell my pipeline that you must fail if that security scan fails. Because on its own, a security tool will just tell you that this does not work or this has vulnerabilities. But you as a DevOps engineer must ensure that if something is failing or if something is detecting vulnerabilities, then your pipeline should also fail. or there must be something logged into your pipeline that this something has vulnerabilities. Now you take care how you are configured to take care of it. And who will configure it? It is us DevOps engineers who would be configuring it. Last one is hidden risks accumulate in code and dependencies. I want you to understand that your application is not just the application code. Your application could be depending on several other things. Maybe it depends on Google for authentication. Maybe it is dependent on third-party libraries for some functionality. If I am designing a banking application and my banking application requires a calculator, I will not ask my developers to write code on how to do calculations. I will use an existing third party library for that. And when you start using libraries for your entire application stack, and these, they do not have a specified count. For example, if I have a banking application, I might be using hundreds of libraries, and it is impossible for me to keep track of all those 100 libraries. And as soon as your application progresses, there are new versions of libraries also available. So you must be taking care of all these things. So if you do not have security integrated within your CI/CD pipelines, then these dependencies possess hidden risks. Now that we have this basic understanding, let's understand what is DevSecOps. At a very high level, what is DevSecOps? It is development, security, and operations. So if you are already a DevOps engineer and you have some sort of security in your CI/CD pipelines, then your pipelines already adhere to the principles of DevSecOps. Now, I'm not saying your pipeline is as mature as it should be. What I'm saying is, if you have introduced some component of security, then you have already integrated security with your CI/CD pipelines or with your DevOps flows. Another thing I want you to clearly understand, that whenever I'm talking about DevSecOps, DevOps, SDLC, these are not tools. Okay, these are not products that you can buy. These are methodologies. These are practices that you must apply when you are designing, building, testing, deploying, and even operating an application. So there are, of course, different tools that are available at your disposal to achieve the DevSecOps culture or to achieve the DevOps culture, but in itself, these are just methodologies. Now, which tools you should be using for DevSecOps, which tools you should be using for DevOps, it depends on your application requirements. So what DevOps SDLC they do is they provide you a cultural framework that this is the way things should be done, and as long as you adhere to these principles, you are free to bring in any tools that you want. So in single line, DevSecOps is integrating security tools with your DevOps practices. As simple as that. It is a software engineering approach that integrates security practices into every phase of SDLC and the DevOps lifecycle. And you can see SDLC defines the what and why for your application, and the DevOps lifecycle focuses on how to deliver reliably. Now, DevOps focuses on how to deliver reliably. What is the focus of DevSecOps? DevSecOps focuses on how to deliver it reliably and securely, because when you integrate security with your DevOps lifecycle, you are essentially stepping into the DevSecOps realm of things. Security integrated across plan, code, build, and deploy. That is what we discussed. Automated checks in CI/CD on every push or PR. So whenever you are creating a PR, let's say to merge your feature with your main, then there are automated security checks that are taking place. And what are these security checks? Where do they plug in a production flow? We will look into all of these things in a little while. This gives us clear ownership across developers, security, and operations. Now you could be working in a team where is a different cloud team, there is a different DevOps team, there's a different DevSecOps team, and then there's a different security team in general. So if you have integrated DevSecOps tools into your pipelines appropriately, then you will have clear ownership. For example, if let's say your container scan is failing, I for sure know that this must be looked by my DevSecOps team. So this provides clear ownership. Now that we have this understanding, I want to discuss key DevSecOps terms and concepts that you will hear in your day-to-day communication. I want to start with SAST. SAST is Static Application Security Testing. Now, as soon as I hear static, I know that these are the security testings that are being performed onto a sitting code, and that sitting code could be in my IDE, or that code could be inside a binary or an executable. So static scan of source, bytecode, or binaries for vulnerabilities. That is what SAST will do. Now the topic of this lecture is SonarQube. So if I go to Visual Studio Code here and I go to extensions here and then I search for SonarQube, you would see that there is an extension available that will perform SAST for me. And if you can see, it mentions the same in detail here. And there are multiple other tools. If I write check marks will also have a tool that will do SAST for me, beat vulnerabilities with more secure code. There is another extension, checkmarks SAST is a checkmarks ID extension that enables scanning and retrieving results and so on. So there are tools that can perform SAST for you. Again, when I talk about SAST, DAST, SBOM, SCA, code quality checks, these are again methodologies or practices. These are not tools. There are tools that can perform SAST. There are tools that will help you with DAST. There are tools which will help you with these, and these. So for now, the clear understanding I want you to have is these are just umbrella terms. There are different tools that work under this umbrella to achieve these. Now let's talk about SAST. We already know it is static scanning. It will find SQL injections, hard-coded secrets, insecure APIs, and so on. SQL injections are maybe your application has an input stream, and in that input stream, the malicious user or the malicious machine tried to modify your backend, and your backend is your database, which is SQL. Then where it runs early in CI and integrates with IDEs. We have already seen that there are different extensions that are available for IDEs, and we are also saying that they run early in CI. Now imagine when you are building, let's say, a Java application, that Java application will result in an artifact, and let's say that artifact is in .jar format. So you would want something to scan that artifact for any vulnerabilities. That is where your SAST tool fit. They scan your code, your binaries for vulnerabilities. Now, the first two tools in all the sections are the most popular ones. So you would often see SonarQube and checkmarks in production environments. If your application is containerized, then you could also see Sneak and Trivi as part of your SAST tools. Then let's talk about DAST. DAST is Dynamic Application Security Testing. Now, dynamic means it is performed on applications that are running, and these tests are typically performed using HTTP. So you will have an endpoint on which your application is exposed, and that is the entry point for these tests. Tests running application by simulating real attackers. So it is looking to exploit your application to see what are the loopholes, what are the parts that can be exploited by malicious actors. Targets runtime issues such as XSS, injection, authentication bypasses. Where will you run DAST? You will run DAST predominantly in your staging or pre-prod environments, because you do not want a full-fledged DAST to be running alongside your production application. That does not make sense, because production application has your real users accessing your application. You don't want to overburden your application by performing a full-fledged DAST in production. So what you would typically see is DAST is performed majorly, extensively, I would say, in pre-prod or staging. And when I talk about prod environments, you will still see a passive or minimal DAST running there. There are different tools. First is OWASP, ZAP, Burp Suite. These two are the most famous ones. And if you have containerized workloads, you would also see Sneak DAST is being used for DAST, and there is Sneak that is also used for DAST. So understanding the difference, SAST is for your static code, DAST is for your running code. Then let's talk about code quality checks. Now the first thing that I want to mention here is code quality talks about the quality of code. It is not talking directly about anything security. It is talking about the quality of code. How is your code written? So if I want to explain this to you in general terms. If I want to go from point A to B, and I can go from point A to B straight, but there is another way to reach point B via C, D, E. If I take that longer route, does that make sense? No, right? If I want to go from A to B, I'll go directly. If I am taking the longer route, that decides the quality I am using. So similarly, if I talk about software, if you have multiple duplicates in your code, if you are doing the same things and calling different functions for that, then all these things deteriorate the quality of your code. Another thing is, maybe your code has defined multiple variables which are not being used anywhere. So that says the quality of that code is not good. If something can be achieved in 10 lines of code and you are using 50 lines of code, then that is a code quality issue. So in summary, code quality checks maintainability, complexity, duplication, naming, and dead code. Now, second point is code quality checks helps reduce technical debt and prevent future regressions. Now, technical debt is shortcuts in code or design which are taken to move fast now, and that makes the code harder and slower to change later. So these are technical debts. Then you have code quality checks helps prevent future regressions. Now, what is regression? Regression is to return to a previous and less advanced state. So how code quality helps here is it helps in keeping code clear, tested, and well reviewed, so old bugs do not reappear. Now again, I want you to know that code quality just deals with the quality of your code. It does not directly pertains to security. It pertains to how well your code is written. And understand that it is important that your code quality is good, because you can have certain rules in your SonarQube or code quality tools which will prevent low quality code from going into production. So where you would perform code quality? IDEs, CI for linting analysis and quality gates. Now, what is linting? Linting are static checks which will flag style, formatting, or simple correctness issues before code runs. Now, where you would perform code quality checks, you would perform them in your IDEs and also in your pipelines, and we'll see exactly at which stage of pipelines do these methodologies fit into. Dependency scanning or SCA. Now, SCA is software component analysis. Now, with the expanded form, you can imagine that it will tell you all the things your software is comprised of. So for example, if I have a banking application and my banking application has 100 libraries, I'm using 100 libraries in that banking application. What will SCA do is it will tell me what all libraries I am using, and then it will tell me are there any vulnerabilities in my library. So it scans third party libraries for known vulnerabilities and licensing. Now, since it is a software component analysis, it will also give me the licenses that are being used. Now, I want you to know that I could be using 100 libraries and maybe 50 of those libraries are open source, but rest of them, they have a price associated with them. So dependency scanning tools will tell you that. Understand, they are called dependency scanning tools for a reason, because they work on the vulnerabilities in your dependencies. Understand that SAST was used for your static code. Dependency scanning is used to find out the vulnerabilities in your third party libraries that your application is using, and this was used to find vulnerabilities in your code. Matches dependency versions against CVE and license databases. Now, what is CVE? CVE is common vulnerabilities and exposure, and there is a database, central database for these things. What dependency scanning tools will do is it will compare the application versions that you are using with this CVE database to tell you that these are the libraries that have vulnerabilities, and you as application developer or DevOps engineer will have to fix those vulnerabilities. And next one is where you would run this during build and CI, continuous dependency scanning runs. There are tools available for this. Sneak and Trivi are the most popular ones. Now, at this stage, I want to tell you that SBOM is an extension of SCA. Okay, but fundamentally their primary purpose is different. So when I talk about SCA or dependency scanning, the primary purpose for them is to list out the vulnerabilities that are there in your third party libraries. The primary purpose of SBOM is to give you a machine readable inventory listing, components, versions, and licenses. Understand, dependency scanning was actually performing a scan and telling you about vulnerabilities in your third party libraries, whereas SBOM is just giving you an inventory. It is just telling you that these are the 100 libraries that you are using, and this is the version of it, and this is the licensing for this, and these are rest of the components that your application is using. So it is just fetching the inventory. So for example, if I talk about AWS cloud, I could have a script that fetches me all the EC2 instances that are running, but I could also have a script that fetches the instances and also deletes the instances that are in powered off state. So these two things are different. Similarly, if I talk about dependency scanning, it is actually finding the vulnerabilities for you in your third-party libraries, whereas SBOM is just giving you the version of those libraries in short. And then you see licensing is there in both of this. Now, this is an overlap, of course, but I said primary function of SCA is scanning third-party libraries, and primary function of SBOM is to give you machine readable inventory of the third-party libraries version that you are using. And the expanded form for SBOM is software bill of material. Generate SBOMs in CI and attach to artifacts. Enable post-release rescans when new CVEs are published. Now understand, if you didn't have SBOM, then you will have to run the scan on the running application or onto the artifact that was generated. For example, if you are working with a Java application, then when there was new releases in the CVE, when the CVE database was updated, you would have to compare your application with the new database to check out if there are vulnerabilities in your application, right? You will have to compare that with your .jar, or maybe if you have a running application, then you will have to check there. But if you have SBOM and SBOM is already there in your, let's say, artifact registry, then you can directly compare that CVE database with your SBOM and get to know whether there are any vulnerabilities with your running application or not. That is how SBOM helps. But again, I want you to know that if your application at runtime is installing certain softwares or using certain libraries, then SBOM will not detect them. SBOM will only detect those things that were generated at the time when artifact was generated, because SBOMs are typically generated when you are creating an artifact. For example, if you are creating a container image, you can associate an SBOM with it, or if you are creating a .jar, you can associate an SBOM with it, where generated at build time, like I just mentioned, and attached to artifact or images. Next is formats. Now SPDX, Cyclone DX tools that you use are Sift and Cyclone DX plugin. Now these are the formats in which SBOMs are generated, and these are the tools that generate these SBOMs. Now in summary, SAST is static code checks, IDE plus CI. SCA is dependency scanning, SCA software component analysis. Then you have SBOM, inventory of components, software bill of material. DAST is dynamic application security testing. It is performed during your runtime. It provides you with runtime security. Code quality is equal to maintainability checks, IDE plus CI. Now I want to emphasize on one thing again, that code quality is not directly security related. It just tells you how is the quality of code. So keep that in mind, and I will tell you why this distinction is important as we progress with this lecture. Now I want to discuss SonarQube. What is SonarQube? It is a continuous inspection platform that automatically analyzes source code for bugs, security vulnerabilities, code quality issues, and test coverage, enforcing consistent standards across CI/CD pipelines. So essentially, whatever key terms that we discussed before, we mentioned SAST, we mentioned code quality, we did not mention code coverage, but we did mention both of these. So if I move to these concepts, SAST and code quality is something that SonarQube will help you with, and how it helps we will see it practically as well. But let's first understand that what is code coverage. So at a very high level, we know that SonarQube will help us with three main things: code coverage, SAST, and code quality. So let's quickly understand what is code coverage. Now let's say you have written 100 lines of code, and when you are testing, you are only testing 80% of it, then your code coverage is 80%. So as simple as that. Code coverage is how much of your code is tested to work properly. Again, mark my words, I said how much of your code is tested to work properly. I did not mention anything about security. So if your code is supposed to perform 1 plus 1, if it can perform 1 plus 1 properly, and you have tests defined to test that, then your code coverage is 100%. But 1 plus 1 testing is not security, right? Here as well, if you are performing code coverage, it will tell me how much of your code is tested to work properly. It is not telling me that your 80% code is fine when it comes to security. It is not saying that. Next is CI runs tests, coverage reporters generate reports, SonarQube imports. Now this is a critical distinction. Now let's understand this. First, SonarQube, I said, has three main functionalities. This functionality is directly related to security. Okay, this is security, static application security testing. But when I talk about code quality or code coverage, now these are not direct security related things. SonarQube can perform code quality because it is scanning your code. When it comes to code coverage, SonarQube does not perform the code coverage itself. What it does is it depends on other tools to provide that report to it. And once that other tool has provided that report to SonarQube, then SonarQube can decide whether this code adheres to your code coverage rules or not. For example, if I have set my code coverage to 80% and there is an external tool that is sharing the code coverage report with SonarQube, then SonarQube can judge whether your code is adhering to the standard that we have set or not. And based on that, it can also fail the pipeline. But in itself, SonarQube cannot generate coverage reports. So that is what we are saying here. CI runs tests, coverage reporters generate reports, SonarQube imports. Next is enforce minimum coverage on new code via quality gates. That is what I just discussed. So when you are working with SonarQube, what you can do is you can create something called quality gates. Now quality gate is something that stands as a guard. So if your code coverage is, let's say, not 80%, then that gate will not open. And if that gate will not open, then your code cannot move to the next step. And next step could be the staging stage. So it cannot proceed further. And you can have your pipelines fail if the SonarQube quality gate condition is not met. And we will see this in the demo section. Common tools are Jacoco. Jacoco, the expanded form, is Java code coverage. So you will use that for Java. There is Istanbul that you can use for JavaScript. There is coverage.py that you can use for Python. Now I want to discuss SAST from a different lens. Now why different lens? Because here I want to define certain terms for you. And these terms are simple. And once I give you a one-liner, you will have this in your memory for a very long time. So let's see what it is. First is static code analysis to find vulnerabilities, security hotspots, and security sensitive bugs before production. Firstly, what is a vulnerability? Now, vulnerability is a security flaw that an attacker can exploit. As simple as that. Now, your software can have multiple vulnerabilities, and then those vulnerabilities can have different categories. But if I have to define it in one line, then vulnerability is a security flaw that can be exploited. What is a security hotspot? Security hotspot is something insecure that is there in your code. Now that something insecure is not impacting the functionality of the application, but it is a security risk. For example, if I have secrets in my code, that is not impacting the functionality of my application. My application would still work fine, but it is a security hotspot. It is a security flaw. So in summary, security hotspot is a code that might be risky and needs human review. Now, why I say might be risky? Now, there is a chance that you are internally using a private CA to sign your certificates, and that is how your application is meant to be. In that case, that security hotspot can be ignored. Next is security sensitive bugs. Now, when I talk about bugs, bugs have typically the highest priority to be fixed. Now, if you have a bug implies something that causes application to not behave as expected. So fixing bugs have the highest priority. Here we are saying SAST can also detect security sensitive bugs before production. Next is categorizes findings by type and severity. So SonarQube can do all these things that we discussed here, and then it can also categorize finding by types and severity for prioritization. Runs in PR's CI to shift security left, and this is what we will see in the demo. Now let's discuss code quality. Code quality at a very high level, we know, tells us whether the code is well written or not. Now first is detects code smells and duplication. Now what is code smell? Code smell is a poorly written code that makes changes harder. Duplication, as we all know, duplication is you are repeating the same part again and again. You could also create a function for that. So that is duplication. So SonarQube will detect these things, primarily about maintainability, readability, and technical debt. So SonarQube can help with code quality because SonarQube will tell you how good is your code when it comes to maintainability and readability. Last one is enforceable via quality gates to prevent regressions. Now, all of these things that SonarQube is somehow administering, SonarQube has the ability to have a gate that if these things are not met, then your quality gate will fail or pass. For example, let's say if your code coverage is not 80%, then I won't open the gate. Hence, the quality gate that we mentioned here briefly will fail. I know I have given you a theory bombardment. You have had different terms thrown at you, and I understand it could be overwhelming for few of you. So that's why what I now want to do is I want to describe an end-to-end production DevSecOps lifecycle so that you know what fits where. And when you know what fits where, you can, of course, at least participate in any DevSecOps discussion with ease. And I assure you, if you understand this flow, you can have security related discussions with your DevSecOps teams in ease. And this will pave the way for any of you who aspire to be a DevSecOps engineer. Now, let me zoom this properly so that whatever I want to convey is in the same screen. Now, the first line is end-to-end production DevSecOps flow, Java plus Maven. So in this flow, we are dealing with Java language along with Maven, which will be used as the build tool for Java. Now, the pipeline that you see here is platform agnostic. So GitLab, Jenkins, or GitHub Actions, or whatever you are using, this flow is platform agnostic. This is essentially the methodology, the thought process that is behind DevSecOps. The key point in DevSecOps, as we understand now, is security. How do we integrate security at each stage? So that is what we will be doing in this workflow. The first point is check out from private repository. Now that is what will happen always. Your production code will be stored in a private repository, and from there you will be checking that code out. Now, if I talk about a containerized application, your repository will have source code, that is obvious. If I talk about Java, it will be your src and then pom.xml, and it will also have the Docker file. Docker file will be used to create a container image, and then it will be pushed onto a central image registry, and then containers will be created using that image. Second point is triggered by push or pull request. Now, you will never, in my opinion, see any production pipeline getting triggered on a push. Typically, your main branches or your production branches are protected. So you can only raise a pull request. For example, you are working on a feature branch, and once you have done your work, what you would do is you have performed your pushes. What you would do is you would create a pull request. And as soon as your pull request is created, your pipeline will trigger. The second step is build plus test. Now, before I start this discussion, I want to talk about testing in general. So if I talk about testing, there are two parts to testing. There is functional testing and then there is security testing. And often people will just say testing, and you, based on the communication, will have to understand whether that person is talking about functional testing or security testing. And as you spend time in this industry, you will understand these things, no biggie. But I wanted to give this distinction to you right here so that it eases the terminologies that are thrown at you. Okay, so testing, there is functional testing. Now functional testing implies whether my application is working or not working as expected. Okay, it does not deal with security at all. Second is security testing. Now security testing is something that deals with security. So you will have methodologies like SAST, DAST, SCA, SBOM here. And security testing also deals with supply chain. So if I talk about SBOM, what is SBOM? It will tell you what your software is comprised of, the versions. SCA will tell you vulnerabilities that your libraries will have. So they also deal with supply chain. So two things: functional testing and security testing. So when I talk about code coverage is part of functional testing. It is not doing anything security. So I hope this distinction is clear. Now that you understand this, let's move to the right of the screen. So I'll make this here. And then second point is build plus test CI phase. Now first thing is, see, if I talk about Java, there are first testing frameworks that must be defined by your developers in the code. First is those testing frameworks, and JUnit and TestNG that you see here are those testing frameworks that must be there in the code. And then what all are the tests that are to be performed using that framework must also be defined by your developers. Only then these testing tools will work. So for example, if I have a Maven plugin and that Maven plugin is, let's say, called Surefire, that Surefire plugin will only be able to perform unit tests if my developers have defined a testing framework like JUnit, and under that they have defined what tests are to be performed. So it is important for you to understand this. Now there are two types of testing that I have mentioned here: unit and integration, and I think I should have explained it in this screen itself. Functional testing checks overall whether the function, your application, is working or not. And then there are some bifurcations. Unit testing will check certain classes in your program, certain sections in your program, whether they are working or not. So unit testing is, you check different chunks of your application separately. Integration testing, as the name implies, integrate things. So it will check whether the process as a whole is working properly or not. Maybe you want to check, if I click on account statement, whether it is taking me directly into my account summary page or something of that sort, whether the components in your application are integrated properly or not. Smoke testing is simple testing. It will just tell you whether the application is accessible or not. So if you have used tools like curl and postman, they are used for smoke testing. So this is this. Now when I talk about this second stage, we talked about unit testing and integration testing. So if I talk about Maven has different plugins that can be leveraged to perform unit testing and integration testing. Surefire is the plugin that is used to perform unit testing, but it can only perform unit testing if you have defined a framework in your code along with the tests that are to be performed. So failsafe is a Maven plugin that is used to perform integration testing, but integration testing again can only be performed if you are using a testing framework like JUnit. Along with that, you have also defined the tests that are need to be performed. So the first section of this is defined by your developers in the code. The second section, the plugin that you have to use, the plugin that are called is typically with your DevOps engineers. And we have discussed this in our Maven lecture, but I will also touch this in the second point. Now, second point is, once these things are defined, second is you would typically run mvn verify. Now, if I take you to my browser and if I go here, we know that mvn verify is a part of the default lifecycle in Maven. Now, if you have not seen Maven lecture, pause this right now and watch that. Otherwise, this will not make sense to you. So if I am running the verify phase, then all the phases that are before verify, 23 phases are there in the default lifecycle, all of these will run. This is important to understand. So when you are running verify, you see there integration test will also run. If I scroll up, test compile will also run, test will also run. So verify will at the very last will also package your application, and once your application is packaged, it can also run integration test. But again, I want you to understand one thing extremely clearly, that unit tests can be performed in an application that is not running. But when I talk about integration tests cannot be performed in a stopped application. And why is that? So unit testing is testing a particular class or a particular section of your code, but when it comes to integration, it is checking your running application. For integration testing, you want the application to be running. So that's the crux of it. So when you run mvn verify, all these things are performed, and you also have a package like you see here, .jar is with you. So let's go back to the diagram again. And now Jacoco records code coverage for SonarQube. Now there are plugins that have performed these tests. Now there is Jacoco plugin that will collect this report, and this report will then be delivered to SonarQube. That is how SonarQube can perform code coverage for you. Now again, I want to clarify one thing. Like I mentioned, integration testing would warrant your application to be in running state. But Varun, we have not deployed your application anywhere. How is it possible to perform integration testing? So if you have been part of our Maven lecture, I think we have discussed that there as well. There is an ephemeral environment that is created. In that ephemeral environment, the application is deployed, and then integration testing is performed. Now let's talk about the third part, that is run SCA and generate SBOM. And as you can see, we are using Trivi to run SCA, and to generate SBOM we are using Sift. Again, you see fail is equal to stop, pass is equal to continue. If this fails, we can fail the pipeline. Again, whenever we are discussing this fail or pass, okay, in these three steps primarily, I want you to clearly know that the tool will just give you the report. Whether to fail the pipeline or not is your responsibility. Now, of course, there are ways via which I can integrate SonarQube with my pipeline, so that if SonarQube quality gate is failing, my pipeline also fails. But that is something that I will configure. So I want you to know that if you want your pipeline to fail upon any of these failures, then you must be configuring your pipeline to fail when these tools are not giving you expected results. Now, what are expected results? For example, maybe for your application, critical vulnerabilities should not be there, but if high severity vulnerabilities are there, you can still pass the pipeline. But for a different banking application, they don't want a single vulnerability. So for them, even a low vulnerability is a vulnerability, and it should fail the pipeline. So you should understand these things. So where SCA is scanning a library and that library does not have a valid license, in that case as well, you fail the pipeline. But you fail the pipeline with logs. You tell them that you are using ABC library and ABC library does not have a valid license. So understand, you can fail the pipeline based on the inputs received from the tools that you have configured at each stage, this stage, and this stage. Another thing I want to highlight is Here I am just concentrating on security. If your Maven or test integration, if your pom.xml is not written clearly, then also this could fail. If you are not running proper commands for containerizing your application, then also this could fail. But I am discussing about security related failures right now, nothing else. Here, run SCA, you have sneak dependency check during build, generate SBOM, and persist with artifact. Persist with artifact is the key point here. I want you to clearly understand that at this stage itself, we already have the artifact. We have run mvn verify, and if I go back to my browser, you know mvn verify will also run mvn package, and if we have run mvn package, we already have the .jar file with us, so the artifact is already available. And if we have the artifact, then of course we can have SBOM with us. And the next is SonarQube analysis, and you see here this is the icon for SonarQube. Here we have a quality gate. We are saying if SonarQube analysis, if the quality gate fails, then you stop the pipeline. If it passes, then you continue. Now the first point is imports Jacoco coverage reports. Remember, here we generated our Jacoco reports, and here SonarQube is taking an input. Now only when this coverage report is shared, SonarQube can fail or pass the pipeline based on coverage. If you do not have Jacoco or any other means to provide SonarQube with this code coverage report, then SonarQube could care less. In its own, it cannot perform these code coverage analysis. Second is SonarQube will perform SAST and code quality checks. Next is enforces quality gates before packaging, and we have seen this. Here is the part where we are packaging our application. Now I want you to concentrate here. Okay, build, I am saying Docker image mvn jar. I should have run mvn package here, right? But I am running mvn jar. Why is it? And do I even have to run any Maven command here? So let's first understand this. So if I run mvn package, then I will have an artifact with me, right? But why to run mvn package? Because if I run mvn package, all these phases will run again. I don't want that. I only want a jar file. So what I can do is, if you have been through the Maven lecture, the phase for package is I can just run mvn jar. This will just invoke the jar plugin with the jar goal, and this will just generate the jar file for me, and that is what I want, right? Then I should run mvn jar. But another thing that comes to my mind is, why do I run mvn jar? I already have the artifact because I ran mvn verify here. Now until and unless any of these stages are changing my artifact in some way, I don't have to run anything here again related to Maven. I can just use the artifact that was generated here. And this brings me to an extremely critical point. The first responsibility of DevOps engineers or DevSecOps engineers, the lines are blurred now. Everyone is expected to know security. So I'll continue saying DevOps. The point is, the primary goal of DevOps engineer is to reduce the time it takes for the CI/CD pipeline to run, while ensuring whatever things that are needed are performed. So if you do not have to run mvn jar, and if it decreases the runtime of your pipeline by even 1 second, then remove it. Don't keep things that will delay your pipelines unnecessarily. So here I will select this mvn jar, come here, and I will strike this out. So we are not running mvn jar anymore, and we have understood the reason why we are not running. And then we are building an image. We are tagging the image for registry upload. In the next stage, that is push image, we are pushing the image onto a central image registry, and I have taken ECR here, that is Elastic Container Registry from AWS. And understand, along with container image as well, you can upload SBOM I do not have a demo for this, but I will let you explore how do you push both image and SBOM and any OCI compliant image registry like Docker Hub, Elastic Container Registry, or other native registries provided by different cloud providers. They would support the upload of SBOM along with your container image. So feel free to explore this point further. Next point is deploy to staging. Now understand, we are first deploying to staging, and what you should now think is, oh, my application is now running, so there must be DAST performed. So we have discussed code quality and SAST is performed here, SCA and SBOM is performed here, and now we want to perform DAST. So automated application deployment, that's fine. Pre-prod tests run on deployed endpoints, that's also fine. Here is the actual magic that is happening. We are running DAST and smoke tests. Now, what is DAST? We know DAST will point at your HTTP endpoints, the entry points to your application, and it will test whether anything in your application can be exploited or not. And OWASP, ZAP, or burp suite for dynamic checks, you would use curl postman to perform smoke test for app readiness. Now again, like I told you before, a full-fledged DAST will run in the staging, and then once the code is promoted from staging to production, there is a quality gate. So first, the code will only proceed if the DAST has successfully completed. And if the DAST fails, the pipeline fails. And that is something that you will have to configure. OWASP ZAP will not know that it has to fail your pipeline. You will have to write the logic for that. If OWASP ZAP is saying application has critical vulnerabilities, I cannot move forward, then you must have your application pipeline also fail. Now let's say your application is hunky and dory and it is promoted to production. Now in production, you would be using canary or whatever your rollout strategy is. It could be blue, green, it could be canary, A/B testing. There are plenty. So you could have any of those. And then here you will be running only minimal DAST, and that is also called passive DAST. And at the last step, here you see OWASP ZAP, and there is continuous monitoring. OWASP ZAP is there because you could be running minimal DAST, plus you will have your WAF. WAF is your web application firewall for your application, and different observability tools. Now, I want you to clearly know that DAST is not an antivirus or anti-malware, okay? You will still need an anti-malware or antivirus in your virtual machines or in your containers. What DAST is doing, DAST is checking for any exploits that your running application has, and these are tested using attackers. How attackers would exploit your application? They will enter your application using the entry point of your application. It is typically your HTTP endpoint, and that is how DAST is performed. But again, a full-fledged DAST is performed in the staging. But when I talk about actual production, then a minimal DAST is performed. Now, this is the entire DevSecOps flow. Now, I promise you, there is nothing outside this in DevSecOps. There could be different tools that are available at your disposal, but at a very high level, if you have understood these terms, I assure you, you can talk to anyone security centric about DevSecOps, how flow works. Now, of course, there are deeper integrations. For that, you will have to study more, but at a very high level, you are at a very good place to watch any DevSecOps project and understand what is happening. And you all know I always aim for making the foundations strong, and foundations can only be made strong once you know in detail what these things are doing, because doing demos, in my opinion, is easy. What is hard for most of the people is understanding the underlying concepts, and once you understand the concepts, then doing demos are of course extremely easy. Now with that being said, I have a request. So if you are enjoying the channel and learning something new from me, I would really encourage if you could like the video, leave a comment, even if it is just a hi. It helps. YouTube likes that. And share it with your colleagues. I have recently opened channel memberships at a very nominal cost. If you want to support the channel, please consider joining. Now, with that small advertisement, let's start with the next section. SonarQube architecture. Now, before I discuss this, let's go to the GitHub documentation and let's first create some SonarQube. Let's do some labs because too much theory will bore you, right? So let's go to lab 1. So we have done this production flow, and you can visit the GitHub notes. It has details of whatever we are discussing. Okay. So now let's do SonarQube lab. So I'll go to my AWS console. I already have logged in and I'm in Ohio region. I'll click on launch instance. Here I will, okay, good. This is what we all wanted. So we are signed in. I'm in the launch instance section. Let's call this SonarQube. I want to use Ubuntu. Let's use 24.04. Then here, see, I have AWS credits. So if I click here, you see I have some credits. And if you have created a new account, you would also get credits for close to 180 days. And under that free credits, you are not entitled to use any of these instances. You can only use a certain section of instances and they have done enough. So the maximum instance size you can have is 2 vCPUs and 8 GIB, and this is more than enough for most of the DevOps tools that you would be encountering. I'm not talking about AI ML, but for DevOps these are sufficient. And for our use case, I will be choosing C7 flex.large. Now you could maybe get away with T3 small for SonarQube and Jenkins, but I would encourage you to use this if you can. So I'll click here, and I have already created a key pair. That key pair is called Cloud with Varjosh SJ Ohio. I scroll down. I want to use an existing security group. So I have 2 security groups here. One is called Jenkins and one is called Launch Wizard 1. So I will use Launch Wizard 1 for SonarQube, and we'll use that one for the Jenkins EC2 instance. Now, the rules that this security group has are pretty simple. I'm just allowing port 9000 and port 22. So if I go here, this is the default, Launch Wizard 1, SonarQube SG. The security group name is Launch Wizard 1. So if I scroll up, the inbound rules for this one is I'm allowing port 22 for SSH and 9000 is on which SonarQube UI listens. And similarly, we'll see Jenkins when we come to Jenkins. Then I'll go back here and rest looks good to me. This one, I will change it to 20 GI and I will click on launch instance. I'll go to instances, and while this is initializing, I will click here instance actions, and I'll go to image and templates, launch more like this, and this one I will call Jenkins. Okay, and yeah, this one is fine, this one is fine, this is also fine, this is also fine. Here the security group that I want to choose is Jenkins, right? And if I show you the Jenkins security group, it also has the same thing. So it is allowing port 22, and port 22 is being used by me to SSH into Jenkins, and 8080 will be used to access Jenkins UI. Now I want you to know that when Jenkins interact with SonarQube, and you know it will, because Jenkins will be uploading the reports that are generated from Jacoco to SonarQube, it will be uploaded on port 9000, and we have already allowed port 9000 in our SonarQube instance. So that should be fine. So here I will also click on launch instance. Now let's go to instances. Here in the SonarQube instance, I'll just quickly refresh this one, and in SonarQube I'll click on connect. Oh, it's still initializing, so let's allow it some time. The checks have passed. Now let me click on connect. I'll go to SSH client, and here I will just copy this one. So if I go to my terminal, I have already downloaded the key. I'm in .ssh folder, and this is the key that I want to use. And if you see, I only have 600 permissions for this key. Now, if you don't have that, fix the permissions and then you can directly access. Oh, let me, I'll have to recopy it. I'll go here, I'll copy this, and then I will paste this here. Now I'll press enter and this should work. And now I see, are you sure you want to continue connecting? So this is, I will use TOFU, that is trust on first use. I'll say yes. And I will then clear my screen so that we have more real estate. Then I will go to my GitHub notes and we will follow rest of the steps from there itself. Now here I said 22.04, but you can use the latest version as well. So if I scroll down, we have already done this. We have allowed these ports, we have connected, and now we want to change the host name. I'm changing the host name so that it is easy for us. I'll paste this here and it will change the host name for me. Then I want to also change the time zone so that we can see the logs and relate to them properly. And if I now type date, you will see that it is showing me today's date. And then if I scroll down, now I want to install Java. Now you can install Java 21 as well, but I have been working with Java 17 for a very long time and I always click on Java 17, but you can use Java 21 as well. There is no problem with that. So I will copy this one and then I will paste this. And I think Java 17 is deprecating in March 2026, if I'm not wrong. You press here and then I'll press enter. So what we are doing is, understand that here we are installing JRE. JRE is Java runtime. We are not installing JDK. We are installing Java JRE because SonarQube is an application that uses Java. We are not developing or building any application in this server, which is why we are installing JRE. Now, why this is important? This is important because when we go to Jenkins, there we will be installing JDK. Why JDK? Because there we will be building our application using Java compiler. Hence, we'll be installing JDK at that point. Now, the fourth step is install PostgreSQL and create DB for SonarQube. Now, when you are dealing with SonarQube, you can, install it without a database, and underneath, I mean, not without a database, but without an external database, and it would be using H2 database internally, and H2 database is fine for testing and development purposes. But I wanted this demo to be as close to production as possible, which is why we will be configuring a PostgreSQL. Now, for this demo, I am configuring PostgreSQL in the same VM that is running SonarQube, but in production, you would often configure it onto a different VM, or you could also be using a service like Amazon RDS, that is a cloud managed service for that. So let's start with installing PostgreSQL. So I will copy this and this will install PostgreSQL along with common extensions. I will paste this here, let it run, and then I will go back here. I will enable PostgreSQL so that whenever there is a reboot, this service automatically gets started. And then next we will start PostgreSQL. Yeah, let's start PostgreSQL and then we can quickly check the status as well. Yeah, status looks fine. It is active. Now let's do one thing. What we will do is we will go into pSQL and configure the database. So understand that right now we are in shell, which is performing actions onto this virtual machine. But what we want is we want to perform actions in the PostgreSQL instance that we have installed. For that, we'll have to use this super user and we'll be using pSQL to do that. So we'll do this, we'll type it here, and then we are in that UI. Now we will create a login role. Understand that what we will do here is we will create a database and then we will supply a owner for that database. The database name would be SonarQube and the owner for database would be Sonar user. So create role, this use a strong password. For me, both the user and the password will be Sonar. So I will copy this from here and then I will paste it here. So this will create the role for me. This will create the database SonarQube and the owner will be Sonar for this one. I will paste it here. And then next is we'll grant all privileges to Sonar user on this SonarQube database. I'll paste this here and it's saying create database SonarQube owner Sonar. Syntax error near create. Oh, I think I copied both the lines. Is it? I copied the comment. SonarQube does not exist. Okay, I think this command I didn't. Oh, I didn't copy the semicolon. In Sonar as well, I didn't copy. Oh, just wait. This is part of the syntax semicolon. Ah, yeah, create role. Oh, this command also. Oh, this did not give an error. Why? Anyway, so the role is now created. So you have to copy the semicolon as well. Semicolon. I'll paste it here and database is created. Now I will grant access and then we can quit it using this. I'll quit it from here and then I can run the verification. So if I run this, I should see the role. We saw the role is here, Sonar. And then if I run this, this should list the SonarQube database. So SonarQube database, yeah, it is here. And you see access privileges is with Sonar. So this is fine. And then this should not return anything for us right now. I'll paste it. I'll just quit it and then I'll paste it here. I'll press Ctrl A to come at the very front. And then here I will write Sonar. Sonar is my password. I'll press enter and did not find any relation. This is fine because there is nothing connected to this database yet. Nothing connected as in SonarQube instance is not talking with this SonarQube database that we have just created. So I'll clear my screen. I'll go at the top. Now here are few kernel tweaks that you have to do. So I'll just copy them and paste them. You have to do them as is. Do not worry about them. And here also I will do some tweaks that are mentioned here. So you just have to follow the GitHub notes and you should be at a good place. Now in this step, what we are doing is we are creating a dedicated user for SonarQube. And that user we are calling Sonar. So I will copy this. I will paste this here. Now whatever actions that we will perform. So we will be downloading a SonarQube binary. We'll be installing SonarQube. Then what we'll do is we'll give all the rights to that directory to this Sonar user so that we run SonarQube service using the Sonar user because that's the best practice. So if I'm running SonarQube service, I would want a different user for that, not be using Ubuntu user or the root user for that. Now comes the important part, that is download and install. So I'll just quickly open this link to show you something. So if I zoom in, there are different editions of SonarQube that are available at your disposal. At a learning stage, community build edition is the one that you should be using. It covers all the important things that you will be dealing with as part of DevSecOps. And if in enterprise environments, you would typically see enterprise edition or data center edition being used. And you can go to this page and check what all functionalities are available, what are the differences between all of these versions. Here we are using the latest release of community build version. So I will go here and then I will cd into the temporary directory because that is where I will be downloading the binary for this. So I will just copy this command and this will download this specific version for it. Now do not use it 2-3 months down the line. Check the video upload date and if there is a new release, you should be using that. Now I am downloading it as sonarcube.zip. As you can see, -o is sonarcube.zip. And once this is downloaded, what we will do is we'll download unzip software as well, unzip package as well to unzip it. I'll come here, let it complete. I will paste it. I'll go back to the notes again And here there are simple commands. So what we are doing, first we are unzipping sonarcube.zip, then we are moving sonarcube to OPT, and like we have discussed in Maven lecture, when you are installing certain binaries, third-party binaries, you should be installing them in the optional directory, OPT directory, and we are calling this SonarQube current while we are copying it, and that's also fine. And then, like I told you, what we are doing is, for this directory, we are changing the ownership of both user and group to Sonar user. So I will copy all these three commands. I will go here, I'll paste them, I'll press enter. So if I do ls-l on opt sonar, I'll have to add sudo here, SonarQube current. Then you see everything has changed to sonar. That is what we wanted. Now, eighth point is configure SonarQube to use PostgreSQL. Now see, what we want is, we want SonarQube to be using the database that we have just created. So we'll have to point our SonarQube application to the correct database. Understand that we have installed both of these things onto a single VM. Hence, SonarQube application can refer to the SonarQube database with just localhost. If this were a different instance, then you would have to type the host name or whatever means you have defined to communicate with that instance. It could be IP address as well, but in production it is recommended you always use DNS names for communication. Now I will copy this. What I'm doing is, I am editing this file, opt SonarQube current configuration sonar.properties. Now whenever you want to change the behavior of SonarQube, then this is the file that you will be editing, and I'm editing this file as sonar user. You see -u, I'm using sudo so that from Ubuntu user I can invoke BIM using sonar user. So I'll copy this. So I'll go here, and here you see, when I said H2 is there, it is not recommended for production. You can see this line here, it is recommended for tests but not for production. Then you have different options here. We have configured a different database server for us. So what we will do is remove this hash. Here I will be providing the username and password that should be used. So our username was sonar and the password was also sonar. Again, this is for accessing the database, not the Linux instance. So if I go here, what we are doing here is, we are accessing our database using the sonar user. So you see, we created a sonar user and a password was also sonar like we created. So we are supplying this here, not the Linux user that we created. So let's scroll down, and here we have supplied this. Now if you were to use an external database, you have three options. Okay, so you can use Microsoft SQL Server or your SQL Azure, or you can grow Postgre, which we are using right now. You can also use Oracle. And if I talk about here, you can also use Amazon RDS with PostgreSQL as well. So since we are using this, we'll have to perform the modifications in the SQL section. So I am already in insert mode. Here what I will do is, I will first uncomment this, and you see this is the property JDBC PostgreSQL. Localhost is fine because you know my instance is, the database instance is in the same VM. Now what I will do is, at the very last, I will just provide the port number, and the port number from my database is 5432. I think, hold on. Yeah, 5432 SonarQube. 5432 and then SonarQube. That is what we wanted. Now what I will do is escape shift ZZ to save this. I will go at my GitHub documentation. So what we have done thus far is, we have downloaded the binary. In that binary, we have moved it into the OPT directory, and then we have done some changes in the sonar.properties file. But understand, right now SonarQube service is not running at all because we have not created the SonarQube service. So what we will now do is we will create a service for SonarQube, and the service that we will be creating will reside in this path. So we are calling it sonarcube.service, and it is not just this. If your machine is running SSH, you would see that there is also a ssh.service created. These are called unit files, and we'll be creating this now. So let me copy this. I'll paste it here. Okay, and I'll go into insert mode and I will paste this block in this. Now what we are saying here is we are creating a service called sonarcube.service. If I run sudo systemctl stop sonarcube service, then you should invoke this. If I am running start, then you must invoke these scripts, and these scripts, as you know, we have kept the binary in this path, hence we are running it from there itself. So I'll copy this and then I will paste it here, escape shift ZZ. So we have created a unit file. Now, as soon as I do this, I can perform a systemctl daemon reload and my Linux system will detect it. So if I now run systemctl status SonarQube and press enter, then it will tell me that it is disabled, but it is detecting that SonarQube service, and I do not have to write .service here because that is automatically appended. Now I will copy this, I'll paste this here, I'll enable the service, and then let's copy both of these to start the service and then check the status of it. I'll press enter, and now the service is running. I'll press Q, it will exit. Now I will come here. See, I have defined what all things we are doing. You can read it from here. Now if your SonarQube is not starting properly, then you can use these things to troubleshoot. But for now we are done. So let's go here. I will go to instances. I will copy this. I will write http :// I'll add that IP address here, and here I will write 9000 because that is on which SonarQube listens on. And tada, here is SonarQube for you. SonarQube is starting now. Till the time it starts, I want to show you the output for that verification command now, which previously did not give us anything. So we ran this during verification and this did not result in anything. So if I go to my CLI now, I paste it here, I press enter. I have to provide the password, not the placeholder for the password. So let me write sonar here. I'll press enter, and you see it is now listing the tables for me. So it works now. So I'll quit this. I will clear my screen and let's go to our browser, and then let's go to SonarQube. So admin is what is the default password and login. So write admin. I'll log in into this and change password screen. That's fine. Old password is admin. New password is something very difficult to guess. I'll enter my password and then I'll confirm it and I'll press update. Welcome. I'll do later. Got it. And now this is the SonarQube UI for you. Let's do a quick walkthrough of the UI. If I go to quality profiles, you see quality profile are collection of rules to apply during an analysis. For each language, there is a default profile, and that default profile is called Sonar Way. All projects not explicitly assigned to some other profile will be analyzed with the default. Ideally, all projects will use the same profile for a language. Now, quality profiles are collection of rules, and there are different quality profiles created for different programming languages and even for different components. So if you see, Azure Resource Manager also has a quality profile. CloudFormation AWS also has a quality profile. Same with Docker, Flex, Go. Now let's search for Java here. And if I go here, you see there are 537 rules. Now quality profiles are collection of rules. Now this quality profile has 537 rules. So if I go to this profile, I can see what are those rules and what is the categorization of those rules. So if you see security related, reliability related, maintainability related, and I told you when I talk about maintainability and reliability, we are dealing with code quality in general. So if I click on this active rules, it will take me to this rules tab. Now it is listing all the rules for me, and you see it has also defined severity for these rules. So if I go to high, it will tell me all the rules that are created for high priority, high severity. Now, I want you to understand one thing, that you as DevOps engineer, if you are not from a programming background, you might not understand a lot of these things that are going on the screen, and you don't need to understand them deeply. Firstly, you will use a quality profile for a programming language that you are using, and it is often that you could be creating a custom quality profile. And custom quality profile, let's say if SonarWay for Azure Resource Manager has 31 rules, maybe the one you create could only have 25 rules. It depends on what your project demands, and all these rules you will be creating based on discussions with developers. Not DevOps alone will be responsible for creating quality profiles. Here is quality gate. Now quality gate, as I told you, you can have multiple permutation and combinations within a quality gate. For example, I have a quality gate which should fail. I am saying the quality gate should fail. I'm not saying the pipeline should fail. Now upon failure of quality gate, your pipeline is failing. That is something that you have to configure. So here I am saying my quality gate should fail if my coverage is greater than or equal to 80%. So anything lower than 80% should be failing. And then not just this, you can create custom quality gates, and we will see that as we progress with this lecture. Now this is the basic of the UI of SonarQube. Now that we have this understanding, let's go to the SonarQube architecture, and then we will start with our demo. So let's go to my diagrams, and then let's talk about SonarQube architecture. Server stores results and runs rules. Scanners analyze code in CI and push reports to the server. So there are two components. There is a server and then there is a scanner, like a server and a client. So SonarQube server is something that we just installed. So we installed the SonarQube application. We also installed a different database, and that database is running our SonarQube database. And then this is the part we have not touched yet. Server stores the result. So whatever you defined here, the database for this will be storing whatever the results of the scans are, whatever rules are being created. All of those things are stored here. Projects, measures, settings, users. So if you're creating any users, those users are stored there. Your projects, your default settings, all those things are stored in the SonarQube server. And now that we have had a proper bifurcation, so within the SonarQube server, we have a SonarQube application and a different SonarQube database. So you can read here what all things are being stored in the database. So when we are discussing about SonarQube server, understand that I am talking about both the SonarQube application and the SonarQube database. That thing is clear. So central service storing analysis results, metrics, and issues. Provides web UI for browsing projects, triaging issues. So if I go here, you see there is a UI, and in this UI you can create multiple projects. You can create projects locally, or you can set up new projects. And then it is saying runs compute engine evaluation rules, metrics, quality gates. And this we have briefly screened in the UI, and we'll be seeing this in detail when we move to the demo. Next is stores data in DB projects, measures, settings, and users. So all of these things are stored in the DB itself. Exposes HTTP API for scanners, CI, and integrations. Now understand, SonarQube scanner is sitting somewhere else and your CI server is sitting somewhere else. How do you enable integration between these two? For that, you have something called SonarQube scanner. Now, SonarQube scanner, what it will do is it will run in your CI server, and then whatever reports it is receiving, it will send those reports to your SonarQube server. So next, let's discuss SonarQube scanner. It can be also be thought of as the client or the agent. Client that analyzes code and produces an analysis report. So this is the one that is actually scanning the code. Now, when I say scanning the code, it is performing SAST and code quality. Understand that code coverage is not performed by this scanner. This scanner just receives the report and then delivers it to the SonarQube server when it comes to code coverage. Next is runs in CI agents, build servers, or developer machines. That is fine. Reads config, collects sources, tests, and coverage reports. We have already discussed this. Stateless and scalable. So this is an important point. Maybe you have Jenkins in your environment and also have GitHub actions. You can configure a same SonarQube server but can have multiple SonarQube scanners. This point is talking about that. Common variants: Maven, Gradle, generic Sonar scanner. Now that we understand this, let's configure first a Jenkins instance and then let's start with our demo. So I will go to my browser. I will go to instances. I will go to Jenkins here. I will click on connect and I will copy this. I will go to my terminal. I will go to this second tab of this terminal. I will paste this, press enter, go to my, let's first press yes here. Then I'll go to my GitHub notes here. And then I will scroll down, further down. And we have briefly discussed quality profiles, quality gates, SonarQube server, SonarQube scanner. Now let's do the Jenkins lab. So we already have the appropriate security group associated with our Jenkins server. Let's scroll down. Let's do the naming now. We'll change the host name to Jenkins because we like to adhere to the best practices. I'll go here. Then I will change the time zone. I'll press enter. I'll scroll down. Now here you see I'm installing JDK. Install JDK includes JRE, the runtime, plus Java, C, and dev tools needed by Maven, which is why we are installing JDK here. I'll paste it here, press enter, go here. Now these steps are taken directly from the official documentation of Jenkins, so there is no need to explain these points. We are just installing Jenkins. I'll copy these and I will come here, let it complete. I'll paste it here, press enter. Now this will install Jenkins. Once Jenkins is installed, I will run this systemctl associated command so that we enable Jenkins, we start it, and then we'll check the status of it. I'll come here, let it complete. It has completed. I'll paste it here. And then let me go back to the documentation again. So now the installation is complete. I will also run this command so that we know the password for Jenkins. I'll just paste that command here. And you do not have to remember this. When we log into the console, you will see this line there as well. I'll go to my browser. I will come here, instances. I will copy the IP address of my Jenkins instance. I'll come here, http:// I'll add this, and 8080 is the port on which Jenkins listens by default. I'm in the sign in page now. It is showing you can find the password from here. So we have already run that. So I'll copy the password and I will paste it here. I will click on install suggested plugins here. Install suggested plugins. I encourage you to do the same. and this will do the installation. Till that time, let's do one thing. We can install Maven in our Jenkins instance. So what I will do is I'll copy this, and it's simple. And in our Maven lecture, we install this using binary. In production, you would see that often binaries are used to install versions so that their life cycle can be managed outside of the package managers like apt here. I'll paste it here, press enter. This will install Maven, and it will also give me the version it has installed. It will install 3.8.9, and let's check the Maven version, mvn 38, yeah, 387. Anyway, now let's scroll down. Now see, I want you to know why we are installing Maven, why we are installing Docker. The architecture of Jenkins that we are using, our Jenkins controller and the Jenkins executor are both the same. So our controller is the one where we are defining the jobs, and controller is the one which is also acting as an executor because it is also running our jobs. In this scenario, you would want your Jenkins to have Maven and Docker installed. You want to install this because you want your Jenkins server to run Maven and Docker specific commands. I want you to understand that Jenkins at a very high level is just an automation server, right? But that automation server requires tools. If you are asking it to do something, if you are asking Jenkins to do Maven specific jobs, then it must have Maven installed. If you're asking it to run Helm specific commands, then your Jenkins should have Helm installed. If you are asking it to run kubectl commands, then Jenkins must have kubectl installed. But having said that, I also want to mention one more thing. In our architecture, both the controller and executor is the same. In production implementations, you would have Jenkins controller, and that Jenkins controller will be bifurcating the jobs, will be dividing the jobs onto different agents. For example, Docker specific jobs will be running onto Docker agents that have Docker installed. Similarly, Maven specific jobs or Maven specific tasks will be assigned to agents that are Maven specific, that have Maven installed, and so on. And as we move on to advanced demos, as I upload advanced demos in my channel, you would see that we would be leveraging all those things, and not just for DevOps but also for DevSecOps. When I'll be uploading advanced demos, you can always refer to those, because after this lecture you would have gotten a solid understanding of DevSecOps flow in general. Now we have Maven installed. Let's install Docker. Again, all the steps that I'm using are documented in the official documentation of Docker itself. I'm just adhering to that. First step is, if you are working with a VM that is being used for other purposes, I would suggest you to remove this so that you have a fresh installation. I just freshly created this VM, so I'll just move to second step here. I will paste that here, and then I will come here. I will add Docker repository to apt sources, and then finally I will run apt update, and I will install the things that are required for Docker. I'll paste it here. It is installing. While it installs, let's see what we want to do next. Now what I want to do is, what I'm doing is, I want my Jenkins to be running Docker commands. Now for Jenkins to run Docker commands, it must be part of Docker group. Only then it can run those commands. And while I'm on this screen, I'm also making Ubuntu, which is my current user via which I've logged in into my Jenkins server, also part of that Docker group. And then I'm restarting the Jenkins service. So I will copy this first. Let me see whether that has completed, because I don't want to restart Jenkins in middle. It is username. Let's say, let's create a new user here, cloud with Varjosh. Yeah, it's already created here. And I'll give it a strong password. I will confirm my strong password. Full name is Varun Joshi. Email is abc@xyz.com. Save and continue. And here is the Jenkins URL. So I'll save and finish this, and then I'll click on start using Jenkins. And there in my CLI, I was supposed to run that command, right? I'll go here And then let's run all these three commands. I'm not sure. I'll come here, I'll paste those commands here, I'll press enter. Okay, this has run. Now let's run Docker version. Docker versions should run from my Ubuntu user as well, and it is working. So now we have Jenkins server ready, and that Jenkins has Maven and Docker installed. And again, I could have also used plugins instead of directly installing these tools onto my Jenkins CLI, but that is a discussion that we did in our Jenkins CI/CD series. So for now, let's clear our screen. And now let's start with the demo. Now, before I start with the demo, I want to give you a quick glimpse of what we are going to do. So this demo is SonarQube with Docker, Maven, and Jenkins. End to end, we'll be injecting bad code. We will be running Sonar scan. We'll be enforcing quality gates, and then we'll be building a container image and deploying a container. So the first step that we will do is we'll create a private repository. We will upload our code in that private repository. Then we will let Jenkins do rest of it. Jenkins will first check out the code from the private repository. Then we will have Maven integrated with Jenkins. Maven will be compiling the software, and there will be Jacoco plugin. We'll be modifying our pom.xml here. We'll be adding a Jacoco plugin. That plugin will be collecting the test reports and will be delivering those reports to our SonarQube. Then the SonarQube will be performing the scans here, and here those scans imply SAST and code quality scans. Here Sonar gate decision. Sonar will tell whether to allow this pipeline or to fail this pipeline. It will only allow the pipeline if the quality gates are green. It will deny the pipeline to move forward if quality gates are failing. And once the quality gates succeed, we will be creating a container image, and we will be finally running a container from that container image. So that is the complete flow. And in production, the flow that you would see would be similar to this. In addition to this, you would be seeing DAST, SCA, SBOM, and so on. So let's go to our GitHub nodes and see what we want to do. So the first step is we want to create a private GitHub repository, and then we also want to create a token. Now, why we are creating a token? We are creating a token because this is the token that our Jenkins will be using to interact with our GitHub repository. So I will copy this name. I will go to my GitHub repository here. Let me scroll at the top here, and then I can go to the home page. Here I can go to repositories, and then I can click on new repository, and here I can give a name to this repository. Let's call this cloud with Varjosh private repo, and here I want this to be private, and I will click on create repository. That's it, a repository is created for me. Now I want to create a personal access token, because that is how my Jenkins will access my private repository. So here I will go to settings, and then in settings I want to go to developer settings, and in developer settings I want to go to personal access tokens. Here I'll go to tokens classic, and then I will click on generate new token. I want to generate a classic token. Here I can call this Jenkins GitHub integration. I want the names to define exactly what I'm doing. Please pardon the long name. Now I will have repo selected, and then I will click on generate token. So I'll be deleting this token after this lecture. After uploading this lecture, there is no point remembering this. So what I will do is I'll copy this. You will be only shown this once. So copy it and paste it somewhere safe. So I'll go to my Visual Studio Code, and here I'll go to this file and I will paste my GitHub token here. Then I will go to my browser. So we have generated the token, we have created the private repository. Now what I will do is I'll go here to my steps again, and I'll scroll down. Now see, now is the step where we are creating a Maven project. So this is the project that where we will be running all our security scans. Before I run this step, I will be using my Jenkins VM to run these steps. But if your laptop has Maven installed and Git installed, you can run it from your own laptop as well. I am using my Jenkins server so that the larger audience can follow along with me. So I'll be CDing into the temp directory, and then we have already seen this. We are using Maven archetype quick start with version 1.5 here. So we have discussed this bit by bit in our Maven lecture, so I'll not spend any time discussing this. I'll copy this. I'll go to my Jenkins VM. I'm on Jenkins VM. I'll paste all of these here. I'll press enter. I want you to clearly know what we are doing. We are replicating an actual production implementation. We are treating our laptop, our Jenkins server in this scenario, as a developer laptop. So developer, what would developer do? If I press ls, developer will have the code like this, and then the developer will be pushing this code onto a private repository. Those are the exact steps that we will be doing. But before we do those steps, I want you to know the archetype that we are using here, the quick start archetype that we are using. This does not have the Jacoco plugin defined, and the code that is there just says hello world. But I want to show you how vulnerabilities, how code smells will be detected, and how SonarQube will show them. Hence, what we will do is we'll modify a few things so that we can see how SonarQube shows these things to us. So firstly, we will be adding a Jacoco plugin, and you know the plugin information, we put it in the pom.xml. So I'll edit my pom.xml. I'll go into insert mode. I will scroll down where plugins are defined, and I see that you see plugins is a plural here. Here is the first plugin. This is the plugin element, and this is the starting tag. This is the closing tag. For plugins, this is the starting tag, and at the very bottom you would see there is a closing tag. This is the closing tag for plugins. Now this is the closing tag for this plugin. So I'll go into insert mode here, and then I will add my plugin at the very last. I'll press enter, and now I will go to my browser, from where I will copy the plugin that I wish to add. Now this plugin you see is for Jacoco Maven plugin. This will have Jacoco. Now Jacoco, once we have Jacoco, it can share the code coverage reports with your SonarQube. Understand that your surefire and failsafe plugins will be performing unit and integration tests, but it is Jacoco plugin which will be creating the coverage reports. Now I will copy this, and then I will go here and I will paste this here. This has disturbed the formatting a little, and we'll fix that later. So I'll save this. Now if I run ls, you have src and pom.xml. Let me also quickly install apt install tree so that I can show you the structure. I should have added a sudo as well. Sudo apt install tree. So if I run tree now, you can see there is pom.xml, and src has main, which has your main code, and then test has the tests defined. So what I will do is I will add this as part of our code. So what I will be doing is I'll be modifying this code. So right now this code just says hello world, and for our practice that will not suffice. So I'll go here, I will press D10D, that will delete 10 lines. So if you press DD, it removes a single line. If you press D10D, it will remove 10 lines, and 20 it will remove 20, and so on. You get the idea. I'll copy this, and then I'll paste it here. So here what we are doing is we are adding code smell, we are adding a security vulnerability. You remember what we called this? We called this security hotspot, right? And then we are also defining a bug and so on. So let's close this, and we have polluted our code now. So we are good to perform the testing. Now, what is the next step? Let's go there. I'll scroll down. Now let's perform the git commit. So I'll clear my screen first. I'll run ls. You see our code is ready to be pushed. I'll write git init. Git init will initialize this directory. I'll press enter. Initialized an empty directory, which is okay. Git add. I want to add everything that you see, and then I will run git commit, and then -m message could be initial commit with pom and code, right? I have to spell it right. That's why copy pasting is good. I'll press enter. Now let me just quickly also do this. User email is fine. Let's add the name. I will add Varun Joshi here. And now what I can do is let's git branch -v. Now, we have to run git commit. Hold on. Git commit. And then if I now run git branch -v, you see this is the master branch. And in GitHub, we have something called main. And I like the name main better. So let's do one thing. So here is the repository that we created. Okay. So this one, if I go here, you would see that this one has main. So let's do one thing. I will just quickly rename this. I'll write git branch -m main. So we have this main name here. And then what we can do is I can go to my GitHub notes. I will quickly go here, and yeah, we have to add this repository. Now you would have mostly seen that this is usually called origin, and that is the name that is quite popular when I talk about remote. So I usually name my remotes in a way that I can recognize them. So which is why I have not written git remote add origin and then written that URL. I have written git remote add private repo because I want to call this private repo. So once you have done this, now I want to push my code to this private repository. Understand that I cannot push to a private repository until and unless I provide some authentication information. And that is the authentication information I have to provide next. So if I go to Visual Studio Code, if I go to my browser, I have to copy this. I will paste this onto Visual Studio Code. I will copy this personal access token and I will insert this token here. Okay. Then I will copy this. What I'm saying is git remote set URL private repo, this one, so that I can freely push to this private repository. I'll paste it here. I'll press enter. If I run git remote -v now, you can see that that repository is having this URL that we put just now. Once you have done this, run this command with caution. Okay, you should not be showing your personal access tokens. Git push private repo, and then I want to push this to the main branch. So I'll press enter, and this has done the job. So if I go here to my browser and to the repository that we just created, if I hit refresh here, then you see our files pom.xml and src are here. .maven is associated with Maven wrapper. You don't have to know much about it, but understand that this file should not go in .git ignore. Anyway, so src and pom.xml are now here. Now let's see what we want to do next. Create Jenkins freestyle job using execute shell. I am using a Jenkins freestyle job in this demo for simplicity. Once I have advanced demos in my channel, they will be using Jenkins pipeline. And if you are interested in knowing Jenkins pipeline or the pipeline syntax or Jenkins multi-branch pipelines, then I already have detailed demos in my channel which will show you that. But for now, let's stick to Jenkins freestyle job. And anyone who already knows Jenkins would know how to convert these freestyle jobs into a Jenkins pipeline. And maybe when we do advanced demos later in this channel, we will be covering DevSecOps using Jenkins file. So for now, let's create a freestyle job named my app sonar job. So I'll go to my Jenkins screen. Here is my dashboard and my Jenkins is ready. The first thing I want to do is change this to dark mode because this is blinding. Cloud with Varjosh. My password is this. Tab, keep me signed in. And here what I can do is I can, it was in settings and here appearance, and I want this appearance to be dark. It's done. Oh, cancel, save. And then I can go to Jenkins here and let's create a job. And I want to call this job my app sonar job. It's a freestyle job. Okay. Now here I will, now before I forget, let me do one more thing. Okay. I'll go to this pom.xml. It is not formatted properly, right? You have this last plugin is everywhere. And what I will do is I'm deliberately doing this so that you can also see. I'll go to XML formatter. And here what we can do is familiar with this one. Yeah, this one. I'll paste it here. I'll click on format beautify and this has fixed our plugin. Okay. Previously it was, you see, all over the place. Now it has fixed it. So I will quickly copy this. I will go here. I will paste it here. Oh, I'll go to edit mode and then I'll select this all and I'll paste this and I'll click on commit changes. I'm committing the changes from the UI and refactor pom.xml for improved structure. You see how Copilot, how fast it was. Anyway, so I'll click on commit changes and we have the correct structure of pom.xml now. So let's go back to our Jenkins job. Here, source code management Git. Now it is asking us to provide the repository URL. How do we provide that? Let's close this one first. Let's go to private repo. Let's go here. Let's quickly copy this. Yeah, I'll copy this. I'll paste this here. Now again, you know that we require credentials whenever we want Jenkins to access our private repository, and credentials is the place where you configure it. Now it is saying failed to connect. Why failing? Because this is a private repository. I'll click on add here, Jenkins. I will global unrestricted username with password. The scope will be global. Global implies any of the jobs can also use it. Otherwise, a different one is system. With system, only Jenkins and nodes can access it. Username will be cloud with Varjosh. For me, you have to enter your username and password. I will go to Visual Studio Code. I have my personal access token here. I will paste it here. ID, I can call it GitHub. GitHub token seems all right to me. And then I will click on add. And as soon as I select this, this red should go because Jenkins will verify that indeed the person has provided correct credentials for this private repository. And here I don't have a master anymore, so I'll just write main here. I'll scroll down. What will be the trigger of the pipeline? For my pipeline, I'll directly click on build now. So the trigger will be manual here. Now environment. I also have to supply some details about SonarQube, right? And along with details as an IP address, I should also have some sort of authentication for SonarQube, right? And right now in this step, we are defining that authentication. So I'll click on use secret text or file. I will click on add here. I'll click on secret text. But Varun, we have not generated anything for SonarQube yet. How do you intend to provide this here? So we'll be doing that. But first, I want to explain what are bindings. Now, bindings are used to inject secrets securely into the build environment. So you never hard code tokens or paste them into commands. As I told you, in the next step, we'll be adding certain build steps and there will be execute shell. In execute shell, I don't want to enter these credentials, which is why I'm adding these credentials as bindings. And here for GitHub, we added it within the Git section, the source code management itself. So these credentials will not be displayed in plain text in console outputs, and that is what we want. That is why we are using bindings here. Now we must have a project created in SonarQube, and that project will have everything associated with our application, correct? And our application, if I show this to you, is called my app, and that is, if I go here, yeah, this is called my app, my hyphen app. And this is important because GAV parameters are important when we talk about Maven and SonarQube integration, and you will see this shortly why. I go here, I can set up a CI here, but for now, let's create a local project. Now display name, I'm calling it my app. And if I hit on this informational message, the project key is unique identifier for your project. It may contain up to 400 characters. These are allowed with at least with this non-digit. I will click my app, and now I'll write my app, and then we'll press next. Set up new code for project. Now what is this? I want you to understand that let's say you have 1000 lines of code. You have run SonarQube analysis for those 1000 lines. The next time when you run the analysis, do you want to run the analysis for those 1000 lines again? Or would you want to run the analysis for only things that you have changed? I hope you have answered. I only want to run it for the things that I have changed. Understand what I told you. Your primary purpose is to ensure your pipelines run in as less time as possible, covering all what is needed. And to keeping that in mind, you want your security scans to complete as soon as possible. If they are doing the entire scans again and again, isn't that futile? So what this step is asking you is, what do you define as new code? And the options that you have are previous version, and this is the one that we are using. So any code that has changed since the previous version is considered the new code. So let's say a scan was run for your 1000 lines and it found 2 vulnerabilities in. And now in the new code, what you did is you fixed those vulnerabilities. So it will only run on the part that has changed. It will not run it from the very beginning. So that's the crux here. And then you have multiple options here. You can supply number of days. Any code that has changed in the last X days is considered new code. So you have various ways you can define this. For our demo, we will choose previous version, and then we will click on create code. And if you see here, follow the instances default. Default is also the previous version. So you can click on create project now. Now the project is created, but we do not yet have any credentials that we will use to access SonarQube from our Jenkins instance. So for that, we'll have to do 2 more things. First is, let's create a user. I will go here, security, and I will click on users. Let's create a new user, and then with that user we will associate a token, and that token will be used by Jenkins. So I will click on create user, and the login name for this user, I want Jenkins, and then I will also write Sonar so that I know this user is Jenkins Sonar. And then I will also add my app. Why I'm adding my app? Because I know that I created this user specifically for this app or for this project. Now you will not be using user created for Varun or user created for Prakash or user created for Kanika in here. You will be using a different user that is specifically created for integration between Jenkins and SonarQube. So that is what I have done here. Now the password that you provide here is not needed for us because we will not be using this password to access SonarQube, we'll be using token. But since it is asking it, let's provide that password as well. And here the name will be Jenkins Sonar, and ABCXYZ can be the email address. So I'll create this user, and then if I come here, I can create a token. Now token I will call Jenkins Sonar, and then you can set an expiry as well. So I'll click on generate, and now I will copy this token, and this is also shown only once, so it is better if you save it somewhere. So I'll paste it here, and then I will close this. Now what I want to do is, we have a project created, we have a user created, we also have a token associated with that user. But what I also want to do is, I want to give that user system administrator privileges. Now that user is a Sonar administrator. Now I'll click on done. And third thing that I want to do is, I want to define a quality gate. So I'll click on create quality gate. I'll call this my app quality gate. I'll click on create, and you see whatever was there in the default quality gate, those things are already here. And I also want you to see one more thing: projects. Every project not specifically associated to a quality gate will be associated to this one by default. So there is this quality gate that is available here by default. So we'll go here. Now see, if your quality gate fails, you will be reaching out to your fellow developers and tell them that these are the problems, you will have to fix it. It is not you who will be fixing those problems as DevOps or DevSecOps. Your point of concern is ensuring the scans and all these things are running properly and in as less time as possible. So what I will now do is, I will delete all these rules, because our code is not designed for these complex rules for now. So I'll delete all these rules, and then I will add a new condition. I'll say run the condition on overall code, not just the new code. This is important, overall code. And then quality, because I have a tiny code and we'll be running this multiple times. Okay. So I want it to run on the overall code. Quality gate fails when coverage, and see, you have so many options: unit test errors, unit test failures. I will let you explore these options, but here I want to choose coverage, and I'm saying if coverage is less than 80, then you fail this quality gate. I will click on add condition. Now it is asking me which are the projects you want to associate with my app quality gate. For me, these are the projects that are not yet associated, so I want this to be associated. So I will be clicking here. Now if I go to all, if I go to with, I go here, I go here. If I go to with, now you see my app is here. So now we have all the things in place. Now let's go to Jenkins and configure other things. So I will come to my Jenkins screen, and variable I want to use is called Sonar token, and we'll be using this variable in our next step, and I'll show you how. Specific credentials. Now it is asking for credentials. So we have not added those credentials in Jenkins yet. Let's click on add Jenkins, and this is fine. And here I want to choose secret text. Now you would be thinking, but Varun, in GitHub you chose username and password. In here you are just adding secret text. Understand that GitHub expects both username and password, although these tokens are unique. But when it comes to SonarQube, it is just expecting that token, and that token is unique. So I will type that secret here. So let me go to Visual Studio Code. I will copy this. I will paste this here. So whatever ID I give to the token in the CLI or in the Jenkins console, I will be using that ID to call these credentials. So if I click on this question mark, it will give you a gist about it. An internal unique ID by which these credentials are identified from jobs and other configurations. So let us give it an identification called SonarQube-token. This is a good one. If I scroll down, I can click on add here. Now it has selected that token for us. If I scroll down, I will click on build steps, add build steps here. And then I will choose execute shell. I will also expand this. Now let's go back to our GitHub notes. I'll scroll down. I'll scroll further down. We are in the demo, right? Yeah. Now this is the part that I will be pasting onto there. So let's go through this. First, we are listing whatever is there in our workspace. And what will be there in our workspace? Our first step was Git. So it will be performing a Git checkout first. So whatever is cloned will be shown to us when we run this first step. Then we are defining what is the Sonar IP. Now Sonar IP, this will be the IP address of your SonarQube instance. So we'll take it that from the AWS console. Now the third is Maven build plus test plus coverage plus SonarQube scan. Understand what I told you in the architecture part. There are two things to SonarQube. There is a server and then there is a scanner. Now for the scanner part, we are using a Maven plugin that is performing the scanning for us, that is playing the role of the scanner here. But for certain other languages, you will have to install a Jenkins plugin called SonarQube plugin. And this is important. So I'll just quickly show that to you as well. If I open this in new tab, if I go to plugins here, see, saying Java 17 is end of life March 2026. So I'll start using Java 21 from now onwards. I'll go to plugins here. I'll go to available plugins and then here I can check for SonarQube. So you will be installing this SonarQube scanner plugin for certain advanced use cases. For now, we are just using Maven plugin to perform the functionality of scanner. So what we are saying is we are first running mvn clean, which will just delete the target folder. It will perform the cleanup. And we have discussed this plenty of times. If I talk about clean has 3 phases. We are running this phase. It will remove all files generated by the previous build. That is what this will do. Then we are saying verify. Now again, understand this is extremely important. We are running verify, and if you run verify, then all the previous phases are run. So verify will also run the package, integration test, and all of these. So if you have run mvn verify, then you already have the artifact. Keep this important point in mind. So first we ran the clean phase, then we ran the verify phase, and after that we are invoking a Maven plugin named Sonar, and within that plugin we are calling the role Sonar. I hope this is understood. Then we are saying Sonar project key is my app. That is the project key we defined back in the SonarQube UI. Remember, they must be same. Then we are providing SonarQube host URL. This is the URL on which SonarQube is listening. So we have variabilized it, and the variable's value is being picked up from here. Next is SonarQube token. So from where are you picking the token? So we have created a binding, which is why we can call it like this, sonar underscore token. Why we can call it like this? Because I have defined that variable like this, sonar underscore token. Try to create that mental picture in your head right now. And then what we are saying is package. Now this is the important piece. You do not have to run any of these. Why you don't have to run? Because we already have the artifact at this stage. Then why do we want to run this? Hence, we will not be running Maven package, or mvn jar. You could have also thought that we can run that, but that is not needed because mvn verify has already created the artifact for you. And then in step 5, we are creating a Docker file. Understand that this would have resulted in a target folder, and that target folder would have the .jar file. And what we are doing here is we are just copying that jar file and naming it app.jar. We are using an image that has Java runtime environment JRE because we just want to run an application that is based on Java. We are not building a Java application, hence we do not need the Java compiler. And then finally, entry point is this: we are running the application java-jar. App.jar is the artifact that I want to run. So this is my Docker file. Then using this Docker file, I am building my container image. I'm creating my container image. And then in 7th step, what I am doing is I am removing my Java app. Now, why I have added this step, I am forcefully removing this container. Now, if you run this multiple times, then this will give you an error stating the container with this name already exists. So whenever I am kicking in my pipeline, I've added this step so that your pipeline doesn't fail for this reason that this container already exists. Now, I want to let you know one more thing. If you are building image like this, the build context will also have your source code and your pom.xml, and you do not want that in production implementations. You want your build context should only have files that are needed for Docker build. I just wanted to mention this so that you have clear idea. What I will now do is I will copy this entire block. I'll go to my Jenkins UI. I will paste this here. I will go to AWS screen. I will copy my SonarQube IP address. I'll copy this. I'll come here. I'll go to the variable section, and here I will define the value of my variable. Another thing that I want to do is I don't want to run this mvn package unnecessarily because I already have the artifact with me, and I will also comment this one out. This looks fine to me, and yeah, we have added the token. My app is here. Credentials we have provided. I think we are good to apply this. And let me quickly check in the GitHub notes if there is something that we need to do after this. Yeah, this is good. So let's go here. I will click on save and let's click on build now. Now this will trigger the pipeline. Now let's see what happens. Let's click here. Let's go to console output so that we can see what is going on. Okay. The pipeline has failed. And the reason for failure is quality gate status failed. View details on this. Now, before I show you the UI, I want to show you something else. Here, I think I didn't reach here and I directly moved on to next steps. What we are saying here is quality gate wait is equal to true. We are saying you wait for the quality gate. If the quality gate is failing, you fail the pipeline. That is what we have done. The quality gate, we were waiting for the quality gate to either succeed or fail. It failed and we have failed the pipeline. That is what you see here. Now let's copy this and then I will paste it here, and then yeah, let's go to my app. So this will show me the details about my app project, and it says failed. New code is no because we selected overall code, and it is showing all the things that we discussed. Security hotspot 1. So let's start with all of these. So issues, security hotspot, code, measures, activity. Let's do a walkthrough of all of these. If I go to issues, it will tell me about all the issues that are there in my code. Now, again, I'm saying not all of these things would be understood by you, but it is okay as long as you understand them from a very high level. So issues is segregating things based on these are for pom.xml, okay, and these things are for your main code itself, app.java. And then you have test.java has these things. Now again, let's go to security hotspots. If I go to security hotspots, we can see that there was one password and it has said password detected in this. And then we can go on code. It will show you the entire code. Now, I want you to know why this pipeline failed. The coverage is 0%. Now, what does coverage mean? Coverage imply test coverage, right? And I told you that the testing requires developer to define a testing framework and then define test cases, that how do you want to test this, how do you want to test that, and then the plugins that Maven has can perform that testing, but the developer must define the framework and the tests to be performed. In our scenario, we didn't have any of those. We just had the Jacoco plugin. So what Jacoco plugin received was the coverage is 0%. And that is what we see on our screen. If you see source code, the coverage is 0%. If I expand this, 0%. So what I am trying to convey to you is your developers must define test cases. And why this failed? Because we have a quality gate that wanted more than 80% or equal to 80%, but we are giving it 0%. Hence, our quality gate failed. Now, what we want to do is now we want to rerun the pipeline and we want to, sorry, this was the quality gate, but it's saying the same thing. If coverage is less than 80%, you fail it. Now, what we want to do is we want to rerun our pipeline, but this time we want to have it run successfully. Now, in actual production, you would be reaching out to your developers and telling them that fix these problems, only then the pipeline will succeed. But in here, we are the problem creator and we are the problem fixers. So what we will do is we will just delete this condition altogether so that it does not check for this. And then I will come to my Jenkins UI and then I will rerun this pipeline. Build now. And this time, let's see how this works. And then I can go to console output. And this time it should ideally succeed. So it would be running all the steps like we have defined in our execute shell section. And you see it has run everything. And this error is because there was no container with name my Java app, because previous run did not reach this stage at all. It failed in that section itself, in the quality gate itself. Here, then we are creating the container. Now, after creating the container, we are also deleting the container once it has done what it is supposed to do. I hope you have an end-to-end understanding. Let me quickly see if I want to cover anything else. So I have covered everything that I wanted to cover. So that's a wrap for this lecture. In this lecture, we took DevSecOps from concepts to production. You saw why DevSecOps exists, what each security tool category means, and how SAST, DAST, code quality checks, SCA, and SBOM fit into a real CI pipeline. We installed SonarQube, explored its architecture, set up Jenkins with Maven and Docker, and finally ran a full SonarQube plus Jenkins DevSecOps workflow end to end. If this session helped you understand DevSecOps the way a DevOps engineer should, do like the video, drop your questions in the comment, and share it with anyone who wants to level up their cloud and DevOps skills. I will see you in the next one. Thank you very much.